Under pressure. In this module, you will find out what pressure is, how this influences volumes, what equalizing is, why we need to do it, and what the consequent physiological implications are. Analyze the diffusion of sound in water and look at ways of communicating below the surface. Pressure and depth. In the previous module, you learned that an essential feature of the mask is that it allows you to pinch the nose closed from the outside. You also learned that a mask with a reduced internal volume can be equalized more easily. The need for these features derives from a phenomenon that is extremely important for us skin divers. Pressure increases with depth. But what is pressure? In physical terms, pressure is the force exerted on a given surface. Let's look at a practical example of pressure. A person walking on fresh snow will sink into it, while if the same person wore a pair of skis, he or she would sink down less. The weight of the person has not changed. What has changed is that the surface over which the weight is distributed is different. Thanks to the skis, the weight is distributed over a greater area, so each unit of the surface has to support less weight. We usually measure pressure in kilos per square centimeter. This is equal to the force of 1 kilo exerted on a surface of 1 square centimeter. Let's now consider our own planet. It is surrounded by a layer of air that extends from the surface of the Earth upwards for tens of kilometers. This is our atmosphere. Molecules of air have their own weight, which means the weight of all the molecules of air above exerts a force on the Earth's surface and everything found there. The pressure generated is known as atmospheric pressure. At sea level, the pressure generated by the weight of all the molecules of air above is measured as an atmosphere. This is a little over 1 kilo per square centimeter. Climbing to the top of a mountain, the column of air above becomes less, so the pressure will also be less. Let's now go under the water. As you already know, molecules of water are heavier. In practice, a column of water 10 meters high weighs the same as the entire column of air. This is why there is an increase of 1 atmosphere of pressure for every 10 meters of depth. Pressure generated by water is known as hydrostatic pressure. However, as divers, we are interested in knowing the total pressure we are being subjected to, so we use absolute pressure. This is the sum of the hydrostatic pressure and the atmospheric pressure. In this way, we take into account both the column of water above us as well as the column of air pushing down on the Earth's surface. It's therefore easy to understand that on the surface we have a pressure of 1 ATA. We use the final A to indicate that it is absolute, while as we go deeper, the pressure gradually increases. At 10 meters, it is already 2 ATA, and at 20 meters, it is 3 ATA. It is not easy for us to notice these variations, but if we took a balloon filled with gas with us under the water, we would immediately notice that as we descend, its volume becomes smaller. Pressure and volumes. Let's now take a look at the relationship between pressure and the volume of a gas. We have seen that as we go deeper, the pressure increases and the volume of the balloon becomes smaller. The relationship between pressure and volume is said to be inversely proportional, meaning when one value increases, the other decreases, and vice versa. In simple terms, this means that if the absolute pressure doubles, the volume of gas halves. If the absolute pressure triples, the volume becomes a third of its original size, and so on. The only parts of the human body that can